Hello grade 8s. Today we are going to look at volume, but before we're going to start that, we're going to quickly go through our work up to now. When we're going to look at perimeter, we need to know the formulas. So if we want to calculate the perimeter of a square, we add all the sides. The perimeter of a rectangle, add all the sides. The perimeter of a triangle, add all the sides. The circumference of a circle, it's got its own special formula. This one is different, 2 pi r, and we know that pi is 3,14 and r is radius. Next one we're quickly going to review is area. So if we want to calculate the area of a square, it's going to be side squared, that gives us the area. A rectangle is length times width, that's area. A triangle is half times base times perpendicular height. And then the circle, it's pi r squared. Pi is still 3,14, r is still for radius. Now, when we look at perimeter and area, I want you to notice that the sketches that I drew were all flat sketches. So we call that it's two-dimensional sketches or forms. So they've only got a length and a width and so forth. Now, area is the most important of all. So I want you to look at this page while I bring out the formulas for volume. Now let's compare these. First off, volume will be calculated of a three-dimensional prism. So if you compare the sketches, you'll see this one is flat, this one has got a body. Okay, so area of a square is going to be side squared. Area of a cube is going to be side times side, which is side squared, times height. Area of a rectangle is length times width. Volume of a rectangle is length times width times height. Area of a triangle, half times base times perpendicular height. Volume of a triangular prism is a half times base times perpendicular height times height. Area of a circle is pi r squared. Volume of a cylinder is pi r squared times height. So what I hope you'll notice is that these formulas are all very much alike, except with volume, we also multiply with the height. You see? So we multiply with the height there. Now we're going to look at what that height is in a minute. So just keep that in mind. I've made you a cube here. Okay, so a cube is a prism that has 6 sides, and all 6 of those sides are perfect squares. Now when I hold this square like this, you will only see one surface. Now that was when we wanted to calculate area, so we would say side times side. Now when we want to calculate volume, we're also going to multiply with the third dimension, the one that gives it a body, a volume. Okay, so I'm going to say side times height. Now that word height is just a word that we use for the lack of a better word. You could have used depth as well if you preferred. So the height is not necessarily the height like we know it. Height we know is from the bottom to the top. It's not going to be that. It's side, and then it can be times depth, or if I turn it, then that will be height. It will be fine. But you must please try to understand that it's not a height, but it's a third dimension. Now, something very important. If we look at the cylinder, I have this one now that can open, so that's why I'm using this one. If I want to calculate the volume of this cylinder, I want to know how much space is inside of this prism. Now, if I fill this prism with water, it doesn't matter whether the prism is closed or open. It will contain the same amount of water. So if you buy a bottle of cool drink, whether the cool drink is closed or it's open, it's got the same volume of cool drink inside. Okay, so back to this one. So the volume of the cube will be how much space is inside. It's going to be side times height. Let's take a rectangular prism. If I hold it like that, you see the flat surface. We're going to calculate the area of the rectangle, and then times it with the height. Again, doesn't have to be the height from the bottom to the top. It can be a depth, the one that gives it its third dimension. Length times width times height. I didn't have a nice triangular prism, but I made you one. So here we have the triangle. We're going to calculate the area of the triangle, half times base times perpendicular height. So that's going to be information on the triangle. That perpendicular height is going to be of the triangle. And once you've calculated the area of the triangle, you multiply it with the height of the prism. So if I hold it like this, then it's a height as we know it, bottom to the top. But if I hold it like this, we're still going to use this length, but it's no longer a height, it's a depth. But we use the abbreviation height just to learn the formula. Cylinder, we're going to calculate the area of the circle, and then we're going to multiply it with the height of the cylinder. If it's like this, this is still going to be the height that we're going to use, although it's a depth. So if you consider these 4 basic shapes that we're going to work with, I told you when we started, we're going to remember the volumes formula as saying we're going to calculate the area times the height. Now the area we're going to calculate is we're going to calculate the area of the base. Okay. Now the base again is not necessarily the bottom shape. It's going to be the shape that give it its name. So if I take a cube, what is the basic shape of this prism? It's going to be the square. So I calculate the square's area times the height. A rectangular prism, what gives it its name? A rectangle. So I calculate the area of the rectangle, multiply with the height. You'll notice a rectangular prism has got many rectangles. It doesn't matter which rectangle you start with to calculate the area of. If you calculate this one's area, you times with the height, it's going to give you the same answer. Triangular prism, what's the base shape? It's going to be the triangle. I calculate its area, and then I multiply with the height of the prism. Cylinder, what gives it its name? It's a circle. Calculate the area of the circle, multiply with the height or the depth.